Hi everyone, I'm going to show you guys how to integrate this question. So they're basically given in equals to the integration of 0 to pi over 4, which are our intervals, and we need to integrate sec x to the power n dot dx, and we need to find in and I6. So I6 meaning we need to find the integration of sec x to the power 6, right? So these type of questions you'll see in Cambridge advanced level, and you'll see these type of questions in Edexcel exams too. So it's usually in grade 12 further maths, but there are similar MIT questions too that will look like this. So yeah, anyways, so I'm going to show you guys how to do this. So your first step would be, just ignore the intervals for now. Let's just focus on the integration of sec x to the power n. So you could write this as sec x squared, so sec x to the power 2 into sec x to the power n minus 2, right? You could write it like this. Yeah. Now we'll have to use integration by parts. And the formula for integration by parts is this. So you take the term u as the term you can differentiate, and dv over dx as the term you can integrate. So we're going to take u as sec to the power n minus, sec x to the power n minus 2, and we're going to take dv over dx as sec squared x. So now we need to find du over dx, right? So du over dx is basically the differentiation of sec x to the power n minus 2. So how do you differentiate that? So if I write sec x and sec x to the power n minus 2, your first step would be your power. So no, wait, let me write it like this. Sec x to the power n minus 2. So when you differentiate this, the power comes down n minus 2 and into sec x to the power n minus 3, because the power is going to come down and you have to subtract the power by 1, right? And then you have to differentiate of what you have inside. And the differentiation of sec x is sec x into tan x. Well, that's very easy, but if you guys want me to show that, please drop a comment. I'll help you guys out with that. So then du over dx is going to be n minus 2 into sec x into tan x into sec x to the power n minus 3. Okay? But now, since you have sec x here and you have sec x here, right? So this is basically sec x to the power 1, right? So when you have similar bases but different powers, if you have similar bases and you have multiplication, you can add the powers, right? So you could write your answer as n minus 2 into tan x into sec x to the power n minus 2, right? Because n minus 3 plus 1 will give you n minus of it. So this is du over dx, and we need to find v. So dv over dx equals sec squared x. So how do you find v? We have to integrate. So v is going to be tan x. The differentiation of tan x is sec squared x. Easy. You guys have to know these because these are basics. The differentiation and integration I just did, those are basics. You guys can easily remember those, but if you guys want me to show it, please drop a comment. And if you guys have any doubts so far, please drop a comment too. For now, you use your formula. I'll write the formula again. This is your formula. So u into v. So we found u, which is sec x to the power n minus 2. Yep. and v, which was tan x. So u into v is going to be tan x into sec x to the power n minus 2. This minus v, which is tan x, into du over dx. So this was du over dx. I by mistake wrote u instead. I'm sorry about that. So tan x into du over dx, it's going to be n minus 2 tan x into sec x to the power n minus 2 dot dx, right? So this is what you have. So now, keep this aside for now. And now let's focus on this. Let's focus on our integration. So we have tan x into tan x again, right? So you could write tan squared x. You could take the n minus 2 out. Let's take it out, because it's going to be a number anyways. So we have tan squared x into sec x to the power n minus 2 dot dx. So now you can write tan sec squared x as 1 plus tan squared x, right? So what would tan squared x be? Tan squared x would be sec squared x minus 1. So if you go back to your question, you have n minus 2 into, now instead of tan squared x, I'm going to put sec squared x minus 1 into sec x to the power n minus 2 x dot dx. Now you expand the brackets, so you can see the powers. So when you have powers, you add them, right? Same basis, different powers, doesn't matter, you just add since it's multiplication. So sec nx minus sec x to the power n minus 2 x dot dx is what you get, right, for your integration. This is what we have. Now if I break this down again, I could write n minus 2 into the integration of sec x to the power n dot dx minus n minus 2 into the integration of sec x to the power n minus 2 dot dx. This is what we have, right? So we initially had in equals to the integration of sec x to the power n, right? This is what you had. So if you look carefully on what we got, what would this be? Let me just change the color so you guys don't get confused. So what would this be? That's in, right? If I'll just draw this, that's in. What would this be? Any ideas? This would be in minus 2, right? Because if you have in equals to the integration of sec x to the power n, I'm sorry, I forgot to write x over here. So if you have this, then in minus 2 equals to the integration of sec x to the power n minus 2, right? So now, before writing anything else, let's combine our final answer with what we had previously, because we didn't write this part down, right? So our final answer would be tan x into sec x to the power n minus 2, and there was a minus, remember that? Minus the integration of, so n minus 2, let me just write it again so you guys get it. This But here we had minus, but it's going to be plus because we are multiplying everything by minus now, right? So plus n minus 2 to the integration of sec x to the power n minus 2. Right? This is what we have. Now with what I told you guys previously, we could write this as, so in is our integration of sec x to the power n, so which equals to tan x sec x to the power n minus 2 minus n minus 2 into in plus n minus 2 into in minus 2. Easy. And now, before you go any further, we had powers. Sorry, not powers. We had intervals. Right? We had intervals from 0 to pi over 4. So you could apply those intervals into this. 0 to pi over 4. So since we have in on the right side, we could take it on the left side, right? So you could write in plus n minus 2 in. It's going to go on to the left side. Let's just simplify this. So we'll have in plus n into in minus 2 in. This giving you n minus 1 into in, right? So you can write n minus 1 in equals to tan x sec n minus 2x to the power, not power, intervals, I always say power, plus n minus 2 into in minus. Now you found in, right? So to subject in, you should just divide both sides by n minus 1. That's easy, right? But now we need to find I6. So how do you find I6? So if to find I6, we'll have to substitute n equals 6, right? So when n equals 6, we have 5i6 equals to tan x into sec x to the power 4 with intervals plus n minus 2, which is going to be 4 into I4, right? But now to find I6, you need I4. So we'll have to find I4 first. So how do you find I4? So to find I4, you have to substitute n equals 4, which will give you, so it's 3i4 equals to tan x into sec 4 minus 2, so it's going to be 2 in this, you get the power of 4 plus, so n minus 2, which is going to be 4 minus 2, so it's 2 I2, right? So now you need to find I2. So what's I2 going to be? So we had in equals to the integration of 0 to pi over 4 sec n x, right? This is what we had. So to find I2, we need to substitute n equals 2. So I2 is going to be the integration of 0 to pi over 4 sec squared x, right? So what's the integration of sec squared x? It's tan x. And what are you going to get when you put in your intervals? You will have 1. So your answer for I2 equals to 1. So now you found I2. Let's go and find I4. So I4 So we have 3 into I4 equals tan x to sec squared x 0 to pi over 4 plus 2 into I2, which is 1. So now we'll need to find this, right? You can just use your calculator. You just need to substitute pi over 4 and then subtract after substituting 0. So this gives you 2. So you'll have 3 I4 equals to 2 plus 2, giving you I4 equals to 4 over 3, right? Now using that, you find I6. So 5I6 equals to 5I6 equals to tan x sec x to the power 4 with your intervals 0 to pi over 4 plus 4 into I4. 4 into I4, which is 4 over 3, right? Well, I6 is going to be, so once again, use your calculator for this part. See what you get. So I get 4 plus 16 over 3, the whole thing divided by 5. So I6 is going to be 28 over 15. Therefore, these are your answers. So that's everything for this question. This question is not that hard. So if you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Have a great day. Thank you so much.